Be attentive, because these were the properties very much important regarding your annual examination. Many times they have been asked for 3 or 5 marks. Either they will ask the difference between ferro and paramagnetic material, or else para or dia, difference between these two, or else dia and ferromagnetic material, the difference between these materials they used to ask. If they have asked for 5 marks, means you have to write the 5 differences. If they have asked for 3 marks, means you have to write the 3 differences. Okay. Or else sometimes they will ask the properties of ferromagnetic material for 2 or 3 marks, the properties of diamagnetic, the properties of paramagnetic. They may ask like this for 2 or 3 marks. If they have asked for 2 marks, you have to write 2 properties. If they have asked for 3 marks, you have to write for write 3 properties. Okay. And one more amazing factor here. If you come to know about any one material property, then you can easily say the remaining 2 materials property. If you know the ferromagnetic material property, then easily you can say, or you can write the properties of diamagnetic and paramagnetic. How? Because those properties are interrelated. Okay. Well, let us see. So it is ferromagnetic material. Ferromagnetic. Right? And next I'll write the para. And next I'll write diamagnetic material. Right? Write one by one property with the comparison between all the 3 materials. Be attentive here. The first property. The first property, that is, the ferromagnetic materials are strongly attracted by the magnet. Strong attraction. The ferromagnetic materials are strongly attracted by the magnets. What about paramagnetic materials? They are weakly attracted by the magnets. Right? They are weakly attracted by the magnets. So here the first one is weak attraction. Weak attraction. Then what can we write in the case of diamagnetic material? Obviously they are weakly repelled. Right? They are weakly repelled. Okay. So first one is weakly repelled. So weak attraction. Strong attraction between ferromagnetic material and magnet. Weak attraction between paramagnetic material and the magnet. And weak repulsion between diamagnetic material and the magnet. Second one. So here the magnetization is high. Magnetization is high and positive. Magnetization is high and positive. Okay. So next here means magnetization positive means the magnetization takes place in the direction of applied magnetic field. So here the magnetization is low and positive. Right? Low irthudu magnetization. That's why weakly attraction ಆಗ್ತದೆ. So low and positive. Right? Positive means The magnetization will be in the direction of external magnetic field. Okay. Then here the magnetization is low and negative. Low and negative magnetization. Okay. Next, their relative permeability mu r is much more than 1. Mu r means what? Mu divided by mu naught. How that? Permeability of the medium means the ferromagnetic medium and the permeability of a free space. Permeability means it is the ability or capacity of the medium to allow the magnetic field lines to pass through them. So if a more number of field lines were going to pass through the ferromagnetic materials rather than the free space, then what happens? Numerator will be large, denominator will be least. Then the ratio will come much more than 1, right? And here it is slightly more than 1. It is much more than 1 relative permeability in case of ferromagnetic material. So here slightly more than 1. Okay. Here less than 1. Permeability in case of diamagnetic material is less than 1. Okay. And there susceptibility, here fourth one, the susceptibility is high. It is high and positive. High and positive. Here the susceptibility is low and positive, and here susceptibility is low and negative. In case of diamagnetic, susceptibility is low and negative, right? So next, so in the ferromagnetic material, if we place this ferromagnetic material in the magnetic field, if we place this ferromagnetic material in the magnetic field means I'll arrange here a north pole and it is south pole. So here the magnetic field lines will be from north to south. Outside here I have kept the south pole of the magnet. Here one magnet. Okay. It is the south pole and it is the north pole, and here I have kept the ferromagnetic material. Okay, so ferromagnetic material, then all the magnetic field lines will prefer to pass through the ferromagnetic material rather than the air medium or rather than the free space. Means all the field lines likes to pass through the ferromagnetic material rather than or comparatively with the air medium or free space, right? So here around this ferromagnetic material we have the air medium or free space. Then what happens? All the field lines like this, all the field lines wants to pass through this ferromagnetic material rather than free space. ಎಲ್ಲವೂ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ ಥ್ರೂ ಪಾಸ್ ಆಗಬೇಕು ಅಂತ ಇಷ್ಟಪಡ್ತಾವು, ರೈಟ್? ಅದೇ ಇಫ್ ಯು ಗೋ ಟು ದಿ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್, right? Here I'll consider paramagnetic material. Most of the field lines, not all, we can't use the term all, most of the field lines prefer to pass through the paramagnetic material rather than free space. Okay, then that structure will be like this. Look here, most of the field lines I have used here. These are the field lines. So how many field lines we have here? 1, 2, 3, 4, 5. Among 5, most of the field lines were passed through the paramagnetic material. Means 3 field lines. So maximum number of field lines. 3 field lines were passing through the paramagnetic material. Okay. Then, in case of diamagnetic material, in case of diamagnetic material, so here in a magnetic field I have kept a diamagnetic material. So here most of the field lines prefer to pass through the free space rather than the diamagnetic material. Okay, andre inta right, ee tara. So most of the field lines prefer to, so all the field lines, I'll not use most of the field lines, all the field lines will prefer to pass through the free space rather than the diamagnetic material. Okay, the next one, if you keep this next property, it is fifth property, I think. No, it is the fifth one. Next one, sixth property. If we kept the ferromagnetic material in a non-uniform magnetic field, non-uniform means let us consider one side strong magnetic field ಇರ್ತೈತಿ, ಇನ್ನೊಂದು ಸೈಡ್ ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಈ ರೀಜನ್ ಒಳಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೀಕ್ ಇರ್ತದೆ, ಈ ರೀಜನ್ನಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರಾಂಗ್ ಇರ್ತದೆ, ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಈಗ ಇಲ್ಲಿ ನಾವು ಒಂದು ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ನ ಇಟ್ವಿ ಅಂತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಟೆನ್ಸ್ ಟು ಮೂವ್ ಫ್ರಾಮ್ ವೀಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಟು ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಯಾಕೆ ಹೇಳ್ರಿ? ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಅಟ್ರಾಕ್ಟೆಡ್ ಬೈ ದ ಮ್ಯಾಗ್ನೆಟ್. ಯಾವ ಸೈಡ್ ಜಾಸ್ತಿ ಅಟ್ರಾಕ್ಟ್ ಆಕೈತಿ, ಯಾವ ಸೈಡ್ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಐತೋ ಆ ಸೈಡ್ ಜಾಸ್ತಿ ಅಟ್ರಾಕ್ಟ್ ಆಕೈತಿ, ರೈಟ್? ಓಕೆ, ಸೊ ಇಟ್ ಟೆನ್ಸ್ ಟು ಮೂವ್ ಫ್ರಾಮ್ ವೀಕ್ ಟು ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆರಿ ಕ್ವಿಕ್ಲಿ. ಅಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್, paramagnetic material. If we keep in non-uniform magnetic field, paramagnetic material itvi andre, it is also tends to move from weak to strong magnetic field. And when we come to diamagnetic field, when we keep this diamagnetic material inside the non-uniform magnetic field, it wants to move from strong to weak magnetic field. ಯಾಕೆ ಹೇಳ್ರಿ? there is a force of repulsion, ರಿಪೆಲ್ ಆಗಿರ್ತೈತಿ. ಯಾವ ಸೈಡ್ ಜಾಸ್ತಿ ರಿಪೆಲ್ ಆಗಿರ್ತೈತಿ? ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಕಡೆಯಿಂದ ಸ್ಟ್ರಾಂಗ್ ರಿಪಲ್ಷನ್ ಆ್ಯಕ್ಟ್ ಆಗಿರ್ತೈತಿ. ಸೊ ಅವಾಗ ಏನಾಕೈತದ? ಸೊ ವೀಕ್ ರಿಪಲ್ಷನ್ ಇರ್ತದೆ, ಓವರ್ಕಮ್ ಮಾಡ್ಕೊಂಡು ಏನು ಮಾಡ್ತೈತಿ? ವೀಕ್ ಫೀಲ್ಡ್ ಕಡೆ ಮೂವ್ ಹಾಕಿ ನಿಂದಿರ್ತೈತಿ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಓಕೆ, then if we keep this ferromagnetic, next property, eighth property, seventh property ಒಳಗಡೆ if we keep a ferromagnetic material inside the magnetic field, okay, inside the magnetic field, if we keep the ferromagnetic material, quickly it points in the direction of magnetic field. ನೋಡ್ರಿ, ಹಿಂಗಿಟ್ವಿ ಅಂತಂದ್ರೆ quickly it points in the direction of magnetic field. In case of paramagnetic material, if we keep a paramagnetic material in a magnetic field, uniform magnetic field like this, it slowly points in the direction of magnetic field. ಅದೇ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಹೋದ್ವಿ ಅಂತಂದರೆ, ನಾವು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇಟ್ವಿ ಅಂತಂದರೆ ಇಟ್ ಕ್ವಿಕ್ಲಿ ಟರ್ನ್ಸ್ ಇನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಟು ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ನೋಡಿರಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹಿಂಗಿರ್ತದೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಇದೇನಾಗ್ತದೆ ಅಂತಂದರೆ, ನಾವು ಇಟ್ವಿ ಅಂತಂದರೆ ಕ್ವಿಕ್ಲಿ ಆರ್ ಇಟ್ ವಿಲ್ ಅಲೈನ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಇಟ್ ವಿಲ್ ಅಲೈನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈಕ್ ದಿಸ್. ನೋಡ್ರಿ, ಇದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅದನ, ಇದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ನನ್ನ ಕೈ, ಆ್ಯಂಡ್ ಚಾಪೀಸ್ ಏನದಲ್ಲ ದಟ್ ಈಸ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಯಾಕೆ ಹೇಳ್ರಿ, ಈ ಸೈಡಿಂದನೂ ರಿಪಲ್ಷನ್ ಇರ್ತದೆ, ಈ ಸೈಡಿಂದನೂ ರಿಪಲ್ಷನ್ ಇರ್ತದೆ, ಮತ್ತೆ ಏನಾಗ್ತೈತದ ಹಿಂಗೆ ಟರ್ನ್ ಆಕೈತಿ. ಇಟ್ ಪಾಯಿಂಟ್ಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ magnetic field. Is it clear? Then last property, and very important property, ferromagnetic materials obey the Curie law above the Curie temperature. Ferromagnetic material Curie law ನ ಒಬೇ ಮಾಡ್ತಾವು ಯಾವಾಗ? above the Curie temperature. ಯಾಕೆ ಹೇಳ್ರಿ, ಈ ಕ್ಯೂರಿ ಲಾ ಕೊಟ್ಟಿದ್ದು ಯಾವುದಕ್ಕೆ? ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ಗೆ. ಸೊ ಫೆರ್ರೋ ಪ್ಯಾರಾ ಆಗಿ ಯಾವಾಗ ಬಿಹೇವ್ ಮಾಡ್ತೈತಿ? ಅಬೋವ್ ಕ್ಯೂರಿ ಟೆಂಪ್ರೇಚರ್. ಸೊ ಅಬೋವ್ ಕ್ಯೂರಿ ಟೆಂಪ್ರೇಚರ್ ಫೆರ್ರೋ ಪ್ಯಾರಾ ಆಕೈತಿ. ಸೊ ಅವಾಗ ನಾವು ಕ್ಯೂರೀಸ್ ಲಾನ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ನೆಕ್ಸ್ಟ್, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ ದೇ ಒಬೇ ದ ಕ್ಯೂರಿ ಲಾ. ಫೆರ್ರೋ obeys the Curie law above the Curie temperature. Para simply obey the Curie's law. But what about dia? They don't obey the Curie law. They don't obey the Curie law. Okay, this much is enough for today's class. We'll discuss in next class. Remaining we'll do in the next class. Okay, thank you.